Okay, stats, we're to the end of the chapter again, chapter 9. After this chapter, we're going to start kind of a project where we talk about John Baylor test prep, and deal with some of that data. But chapter 9 review, I went ahead and you guys should have access to this. If not, I will post this on Google Classroom. And you might have to print it off, or you can write on a separate sheet of paper or whatever. But I went through this chapter review, and I'm going to give you a couple days to work on this, but I went through and put some notes on here, and I'm going to do a couple of these with you. So I'm going to start off by talking about the first 3 sections. I did not give you on this chapter review, and I won't test you over it either, section 9.4, just because it's kind of an ugly, weird section. So it'll just be 9.1, 9.2, 9.3. 9.1, we talk about proportions. 9.2 is independent means. And then 9.3 is dependent means, where we have the matched pairs, like the same number of boys and girls that we are analyzing data from. Okay. So some of the information that I put down for each one of these is like what section they come from. So if you're trying to look through your notes, number 1, they're asking for the standard deviation of the differences. Okay. So this is your set of differences. And they just want you to find the standard deviation of that. So whether you put that into a Google Sheet, whatever makes it easiest for you, that came from section 9.3. So if you need to look back at that, you sure can. But those are your differences. This is the set of differences. You just have to find the standard deviation there. Okay. I'm going to go ahead and do number 2 with you. 9.1, it says, assume that you plan to use a significance level of 0.05. To test the claim of blah, blah, blah. P1 is equal to P2. That's how I know that I'm in section 9.1, because I'm looking at the P's, okay, or the proportions. You use the given sample sizes and numbers of successes to find the pooled estimate P, okay, or P bar. P bar is represented in round the answer to the nearest thousandth. Thousandth is 3 decimal places. 3 decimals. I had to think for a second. 3 decimal places. So P bar, if I look at section 9.1, if I refer back to those notes, P bar right here is just adding, it's basically finding the average of the x's divided by the n's. So x1 plus x2 divided by n1 plus n2. Okay, so I'm just adding my x's together. 172 plus 654, and I'm dividing by the n's. So 677 plus 3377, and that will give me my pooled estimate. Okay, so I'm going to use parentheses. Parentheses 172 plus 654, close parentheses, divided by 677. Let me open parentheses again. 677 plus 3377. Okay, and my pooled estimate to 3 decimal places, 0.204. Okay, that will give me my pooled estimate. Okay, now I put a little line down to number 4 because number 4 is asking to find P bar also. Okay, so they're asking for the same type of thing. So if you want to, you can pause the video if you want to and do that one now. But that's kind of the same type of thing. Okay, number 3 and number 5 are very similar to each other as well, and I'll do number 3 with you. So construct the confidence interval for the difference between 2 population means. Okay, so we're doing means. So I'm either looking at section 9.2 or 9.3. And we need to figure out, are they independent samples or are they dependent? Okay, so assume the 2 samples are independent. There we go. Okay, that tells me exactly what I need to know. So I know that I'm looking at section 9.2. Okay, so I'm going to go find that paper, and that is going to tell me, I want to find the confidence interval. So I want to do this guy. I want to figure out what this thing is, that big long thing that I have going on. Okay, so I need to figure out what the error is, and then I have x1 bar minus x2 bar. Okay, so we're going to do that real quick and find this stuff. So x1 bar, x2 bar, s1, s2, that's all the information that I have. It says the sample size is 478 for both samples. So N1 is 478 and N2 is 478. Okay. Now, when we went through and did means, anytime you're doing a mean or an average, if your test statistic is, or if your n is bigger than 30, you can use the z-table. If your n is less than 30, you have to use the t-table. So I'm going to use the z-table for this one. Okay. All right, so my confidence interval, I'm just going to write this all out. x1 bar minus x2 bar minus the error is less than, they want us to find the confidence interval for mu1 minus mu2. So that's going to stay there in the middle. And then I have x1 bar minus x2 bar plus the error. Okay, so I just really need to figure out what this number is and this number is. Okay, this mu1 minus mu2 is going to stay in the middle there. Usually we replace that with 0 if we're actually doing a hypothesis test, but they're just saying find the confidence interval now. So they want an 85% confidence interval, so we just need the error here. Okay, formula for error. Lots of sheets to flip around with here. Okay, confidence interval for error is that t, or in this case it's going to be z, is what we're going to use, z of alpha over 2, square root of s1 squared over n1 plus s2 squared over n2. Okay, so if you don't want to rewrite that, you don't necessarily have to, but I just did. So the z of alpha over 2 for an 85 confidence level. When I'm looking at my, we have 85%. We don't. No, we don't have 85%. Ugh, I don't want to sit here and figure it out. Let's change that. We're gonna fudge this a little bit. We're gonna change this 85%. We're gonna change it to a 90%. How about that? Because I want to be lazy. Okay, so we're gonna do 90%. Okay, so pretend that we didn't just do that. 90%, 1.645. We look down here at this little piece right here. 90%, 1.645. Okay, so that's gonna be the z that I use. 1.645 square root. Standard deviations go here, and those are 77 and 88. And then my N1 and N2, they're both 478s. Okay. All right, so lots of data calculation, but I'm giving you a couple days to do this, so don't be scared. 1.645 times the square root. Square root of 77 squared divided by 478 plus 88 squared divided by 478. Okay. And I got, for an error, I got 8.7, well, let's do 8.8. Okay, 8.79 or 8.8. Okay, we'll do that. All right, now, what I need to do is I need to figure out x1 minus x2 minus the error and x1 minus x2 plus the error. Okay, so here is my x1. I have 958 minus x2, 157, okay, minus the 8.8 that I have. Okay, so 792.2. 792.2. And then I can go back into my calculator and add that error. Okay, so I'm going to change that here to a plus. And 809.8. Okay, so this is going to be my 90% confidence interval for that. Okay, and that's what they were looking for. So number 3 is going to look really similar to number 5, so go ahead and do those. This one's a 98% confidence level. And the difference here is that you are going to need to use the t-table because your n1 is 11 and your n2 is 9. Okay, so maybe to help you out here, your error, when you're trying to find that t of alpha over 2 number, and then you have your square root of all your junk here, okay, you're going to use the smaller of the 2 degrees of freedom. Okay, so when you have this here, I have 11 and 9. The smaller of the 2 would be 8 degrees of freedom because I'm basing it off of the 9. Okay, so on the T chart, I want 98% and 8 degrees of freedom. So I'm going to use 2.896. Okay, So that helps you out a little bit. Figure out what value you're going to use there, 2.896, okay? All right, so that one's a constructed confidence interval there as well, okay? All right, going to the back side, I'm only going to do a few more of these, and then I'll save and do another video to kind of help you with the next set of problems. So number 6, assume that you plan to use a significance level of 0.05 to test the claim, and we're doing proportions again, so P1, P2. Use the given sample size and the number of successes to find the p-value for the hypothesis test. Okay, so we need to, if we were doing this in section 9.1, we would need to figure out our test statistic, okay? And this one's kind of a stinker of a problem, and that's why I kind of picked it, okay? So our test statistic that we're going to use is this huge, big, long formula, that huge one, okay? Maybe we'll do this problem and then we'll stop because I don't want this video to be too terribly long, okay? So they give us some information here, and then we just need to figure out what the rest of this stuff is, okay? So if I'm trying to calculate z, I need to know what p1 hat is. I need to know p2 hat. For this formula, the p1 minus p2, we said that that was usually going to be 0, or always going to be 0, I guess, when we're doing our test in here. I need to know what p bar is. I need to know what q bar is, and then I need to know n1 and n2. Okay, so those basically 6 things are what I need to know, and then this will give me my test statistic. Okay, so P1 hat is going to be based off of your X1 and N1, okay, so it's just the proportion, 8 out of 50, if you need to write the formula in there, you sure can, 8 out of 50 would be 16 or 0.16. The reason I know that is out of 50, if I just double that, that means out of 100, so 8 doubled would be 16 out of 100 or 0.16, okay. P2 is 7 out of 50, 7 over 50, which would be 0.14. Okay, now I need to do the p bar. We already kind of did that a little bit. It would be the 8 plus the 7 over the 50 plus the 50. Okay, so 8 plus 7 is 15 over 100, or 0.15. Okay, q bar would then be 0.85 because we subtract those. Okay, and then for the z, I need to fill in my big, huge, long formula. Okay, all right, so this is what we need to find here. Filling in my z. I need to do P1 minus P2, or P1 hat minus P2 hat, so 0.16 minus 0.14, and then I really have minus 0 on the end of that. So that really doesn't do a whole lot for me. Square root of P bar, Q bar, so 0.15 times 0.85, all over N1, which is 50, and then I have plus that again, 0.15, 0.85, all over 50 again, okay, and then I just need to figure out what that z is, okay, let's see where do I want to start. In the top 1.16 minus 0.14 is 0.02, I know that for sure. Okay, so the bottom, let's do this one. On second square root. Okay, I should be able to do all of this without having to open up any parentheses because the order of operations it's going to do for me already. So if I just do 0.15 times 0.85 divided by 50 plus 0.15 times 0.85 divided by 50. Okay, it should do all of that for me at one shot. Okay, so 0.0714. Okay, last thing, I'm going to take 0.02 and divide by that answer. And I get for my z 0.28. Perfect. Okay. All right, so let's see what it was asking for. Using the given sample size and numbers of successes to find the p-value for the hypothesis test. Okay, so this gives me what z is, and then the last thing that I need to do is figure out what that p-value will be. by looking it up in the chart, and I'm going to be in the positive chart. So 0.28 over here is 0.6103. 0.6103. Okay, or 61.03%. And then what I would do further is then just look and find like where that lives on my bell curve, etc. Right? Okay, but they didn't actually give us a hypothesis test to do. So the p-value here is going to be that 61.03. That's what I want. I'm going to convert it from a z to a p, which is a percentage. Okay, so that one was kind of a booger. That's why I decided to do that one with you. Number 7, I put a little note on here, 9.3. It's going to be similar to number 1, okay, that you did. Number 9.3 or number 8 also goes with 9.3 again. You're trying to find d bar, so kind of make reference to section 9.3. Number 9. This is another find your test statistic, so I underlined that, and that's going to be from section 9.3 because you are doing mean of the differences, and so you have that one. Calculating the test statistic for 9.2 and 9.3 is a lot nicer than calculating the test statistic for 9.1. So it won't be quite as ugly as what number 6 should be. But make reference to section 9.3 for number 9. And then number 10, look at number 9.1. So I said see number 6, because number 6, the one that we just did, is going to help you find the p-value. So let's just find the p-value obtained from this test statistic. Now, the good thing about this is they already tell you what z is. Z is 2.04. So they just want you to find the p-value from that. So you just basically are looking up on the table some things, okay? I'm going to stop you with number 10. Number 11, we're going to go ahead and do together, but I'm going to wait for that one for the next video. So 11, 12, 13, 14, 15, we'll do a few of those together, but I'll wait for the next section to do those with you. So you'll have a couple days to kind of work on this. I am online from 1 to 2 p.m. every day, so if you have troubles, you can hop online. Otherwise, email me, text me, whatever you need to do. Okay. All right. So keep working on those problems. I'll post the next video, and we'll see how things are going. Okay.